Hello, John Merrifield back again with Serious Academics with a Sense of Humor, based on the most important principle of all of life, and fun never ends unless you let it. Well, sometimes other people let it, but mostly you're in charge of that. Mostly you decide how fun to make things, and I'm going to clown around a little bit on this video to make it fun. Most videos, I can think of a way to clown around without stopping it from being serious academics. All right, so today what we're going to talk about is the economics of discount coupons. I bet you thought the discount coupons were in the newspaper because these sellers are introducing something new, or they love you, like a student discount. We love students. You give them a senior discount. I mean, that's one, those are the kinds of discount coupons that there are. No. I mean, maybe they do, but that's not the reason for them. Yeah, that goes away the first time you see a Cheerios coupon, for example. Cheerios, I'm 62 years old, and I can remember eating Cheerios when I'm a kid. I don't think that's a new product that needs to be introduced somehow by giving a discount on it. Okay, and a lot of other things. I mean, sure, sometimes discounts have the dual purpose of, hey, we've got to sell it a little cheaper to get people to give it a try, against the incumbent products. And besides that, it has the other property of doing what it's almost always used for. Namely, separating people who have a greater willingness to pay from those who have a lesser willingness to pay. So those sneaky rascals out there selling stuff have said, look, there's some people willing to pay my full rack rate, as it's called. Like at a hotel, they have a regular rate that they charge and they can get away with it. And then all the other rates, the discounts that they give to different people at different times or different times of the week or whatever. And they do that because, well, again, some people are willing to pay that high price. They have money, trying to save themselves the time, don't want to look around, or, it's just an impulse buy. They saw it and their friend has it and they want one and they've got to have it. Boom, go buy it right now. Sales are, that's another example of what we're going to talk about here, namely third-degree price discrimination. Again, it's a way to separate people who want it now and who can pay for it from those who are a little tighter in the budget and are willing to shop around a little bit. Time cost. Clipping coupons, time cost. All right, so that's the method of separating the different groups, the time cost of the coupons. Got to clip them, got to carry them around, okay, and so some people will bother with them and other people will. Okay, so we want to charge some folks the high rack rate without losing as customers those who will not pay it, right? So to keep the, right, if it weren't for coupons or sales or other things, the price would be somewhere in between that at all times. Okay, so it's a profit-producing practice. All right. So again, just some things that I've been saying, but it's kind of hard to follow along and try to copy it all down. So the economics of discount coupons: it's profit increasing when separable groups. You see, the coupon at the time cost is the way to separate the groups with higher and lower willingness to pay. And then the measure that you need for deciding how big to make the discount coupon for these separate groups is the price elasticity of demand. Okay, so if we know that some groups of people that are delineable, right, students, non-students, seniors, non-seniors, impulsive people, not impulsive people, whatever, if we can delineate them and then measure the price elasticity of the different groups, then we can estimate how big of a discount coupon to create in order to maximize our profits by charging different prices, in effect, to different groups. Okay, now this idea of using the price elasticity of demand to figure out a profit maximizing coupon is based on the marginal revenue definition. Again, for those of you not familiar with this economics terminology, marginal revenue is the change in the total revenue when you produce one more of something. So, for example, let's say you could sell 5 of something for $6 each. Okay, 6 times 5 is $30, right? Okay, and if you wanted to sell, say, 4 of, you wanted to sell a bit more, you wanted to sell 6 of them. Okay, so 6 of them, what would you do? You'd have to charge, say, $4 each. Okay, so I used too many 6s. Let me just back up on that. Let me try that over again. Let's say that if you priced it at $9, you'd sell 2 of something. $18, right? Okay, and if you lowered it to $8, then you'd sell 3. Okay, so 2 times 9 is 18. 3 times 8 is 24. Marginal revenue is 6. 24 minus 18. Okay, where'd that come from? You had to sell the first two. You could have sold at $9 for $8 in order to sell that third one. So that cuts into the revenue from the third one, the $8 that you sold it for. You sold the other two for $1 less, so 8 minus 2 is 6. 24 minus 18, 6. Okay, so here on this thing that I'm still holding up, we can use this definition to derive what you probably want to call a formula, although I think it's just based on an understanding of the concept. But all right, this is as close to a formula, I suppose, as we're going to come to in this basic stuff. Okay, so we can multiply anything we want by 1 and not change it. So we're going to multiply by P over B. Wow. And we factor out the P, and so the thing that MR equals now looks as follows right there in that line. Okay, again, the nice thing about the video is you can freeze this and look at this later. You can stare at it as long as you want. But yeah, maybe not that frame. Okay, and then put the MR back in there and factor out the P, and we have our little formula. Right, how's that a formula? Well, let's see. To maximize profit, you want marginal revenue equal marginal cost. So you plug in the marginal cost number or equation here. Okay, and you plug this in over here, and you go hire a consultant to find the price elasticity of demand for the separable groups. And then if you run this equation for each of the groups, right? And don't forget to use the minus sign, right? Most of the time you're told to add. It needs a minus sign. The thing that matters about the elasticity is that it's its absolute value. Right? We know it's a minus sign. Here, you better not forget it. If you forget to put the minus sign in here and crunch these numbers and thoughtlessly hand the result to somebody, you're likely to get yourself fired. Okay? Because what you'll be telling them is, boss, I learned this in grad school or wherever you learned it, and I ran the numbers, and it says sell this product for $2.50. The boss will say, we purchased it from our supplier for $4. $4? You telling me I should sell it for $2.50? No. By the way, you're fired. It's a pretty bad Donald Trump imitation, but go with it. Right? The boss is not going to trust you after that anymore. Right? Recommending selling a product for less than they had to pay the supplier for it. Okay, that results from forgetting the minus sign here. See, if you put a minus sign in, then that says that price, that some fraction of price is the same as marginal revenue. Okay, so marginal revenue is less than price, which, yeah, that's right. And which, when you set marginal revenue equal marginal cost, means the price, the price is going to be more than the marginal cost, which is what makes sense operating a business. Right? Now we're saying, wait a minute, shouldn't price equal marginal cost? At the margin, maybe, for some things. Okay, and remember, that's for purely competitive. Otherwise, it's marginal revenue equals marginal cost. Marginal revenue is less than price. Price is more than marginal cost for the vast majority of things. All right, so there you go. Okay, so here's some of that stuff that I just said on this slide. I'll just throw it up there, and then you can look at it again later, and we'll just go right straight to the example down there. Suppose we have a retailer with a constant marginal cost of 7. So take our little formula there at the bottom, and the MR becomes 7, because you're going to want to set the marginal revenue to 7. Could be more complicated. The marginal cost might not be constant. It might be a formula. Well, then you just put that formula for marginal cost, okay, how it changes with quantity, equal to price times 1 plus 1 over the elasticity. Okay, so there we go. Okay, so suppose we have a retailer with a constant marginal cost equal to $7. And we determine that we have two separable groups of customers. Say, by the time cost of clipping the coupons, we can separate Group A and Group B. And we determine that the price elasticity of demand for Group A is -4, and for Group B is -2. Little quick thought exercise. Which of these two groups has the most money, probably? Hopefully you said B, right? Because what those elasticities tell you is that for Group B, there's a 20% change in purchases when there's a 10% change in price. Not that sensitive. I mean, it's still fairly sensitive, but relatively speaking, not so much. Because for Group A, it says there's a 40% chance, 40% change in the amount purchased with a 10% change in price. So clearly, Group B is less sensitive to changes in price than Group A. So If it's an income issue, if you're separating them by income, Group B is the higher income group. All right, so we'll take our -4 and our -2 and we'll plug them into this. Put a 7 there, put the -4 there, and then run the numbers, find price for the one group, put the -2 there, run the numbers, find it for the other group, and then the higher of the two prices is the one we stamp on the product. You can tell I'm old. That's how they used to mark prices on things when I was bagging groceries. Yeah, chunk, chunk, chunk. Okay, and then you put the -4 into the formula because that's going to yield a lower price. Okay, and the difference between the two prices, that's the discount coupon. Right? So, implementation. KG for implementation. Okay, so we do that for the two groups. Okay, my slide shows it in the opposite. Doesn't matter which order you do them in. Okay, so you put the -4 in there. And for that group, then, the profits are maximized by charging them $9.33. For the other group, was it B? Yeah, Group B. Okay, you put the -2 in there, and that means $14 price is what PB equals for profit maximization. Remember, what's the 7? That's the marginal cost. So we're setting this other side, which is the marginal revenue, to equal to the marginal cost. And for Group B, that means charging $14. By the way, notice, kind of a basic, somewhat interesting observation here. A lot of retailers are known to double the cost to get the price, right? So they acquire something for $7, they mark it up 100%, $14. When is that profit maximizing? When the price elasticity of demand is -2. Oh, so that's in reverse. So if you know somebody in the retailing business and you know they do that, or whatever markup level you have, you can work backward and say, that maximizes profit if this is the way your customers behave, right? So, for example, the 100% markup rule from 7 to 14 doubling maximizes profit if the customers, on average, when they all differ, have a 20% response to a 10% change in price. Now, your friend in the retail business, or your mom or dad, if your family's in the retail business, scratch their cheek, say, I don't think my customers behave that way. Well, mom or dad or friend, you better reevaluate your pricing practices. Derive the numbers here for them. They may not be that impressed by that. But you might get them thinking. You might make them quite a bit of additional money, not necessarily of higher prices, maybe lower. Say, wow, I didn't know that. I was charging too much. That demand was pretty elastic. Charged a little bit less and I made a lot more money. Now remember, if they lower prices, they're going to have to come up with a lot more stuff too. That adds the cost. So the additional revenue may not offset the additional cost, but it might. All right. So you charge the $14, and the difference between the 14 and the 933, that's your discount coupon, $4.67. You know, the numbers are all estimates. It'd probably be a $5 discount coupon or $4.50 or something like that. Okay, so by that all the estimates, the -4 and the -2 is an estimate. And as you know, the elasticity, except for some curved demand lines, isn't constant. Okay, so you might make an adjustment for the fact that the elasticity is going to do what? It's going to, let's say you're not using discount coupons. So right now your price is probably between 14 and 967 or 933. So you're saying, okay, I want to raise my prices to $14. Okay, so for Group Group B, the ones with this price elasticity, they're going to be paying more. So they're going to purchase less, 20% less for each 10% change in the price. Okay, so that'll change the elasticity which way? A higher price increases the elasticity. Okay, and then for the other group, with the coupon, they're going to be paying less than they had been paying. Okay, and they're going to pay the $14 price at the checkout, but then they'll say, here's my coupon, and then that'll get marked down, and they'll pay the $9.33. Okay, so their elasticity is what? As you lower prices, the elasticity is going to go down. Okay, so anyway, those are all factors that you think of as you come down to what the coupon is exactly going to be. A $4.67 coupon is kind of awkward. So again, probably $5 would be the coupon in this case. Thanks for listening. That's how you determine profit maximization through discount coupons.